All right, now that we've talked about proportional and non-proportional, I want to actually graph proportional relationships. So how does graphing relationships help you determine whether a relationship is proportional or not? So when you graph it, you should be able to find it right away to say, yep, that's proportional, that's not proportional with an instant. So here's some vocabulary you're going to need to use. Some of these you should already know. Coordinate plane, it's a type of grid formed when two number lines are intersect at 0. It looks something like that. It's a coordinate grid. You have quadrants, 4 different regions, okay, split up. So that's quadrant 1, 2, 3, and 4 that goes counterclockwise. Ordered pairs like 1, 2 is used to locate a point on the graph. So let's take a look. I drew an example here for you of all that stuff. I've got my quadrants 1, 2, 3, and 4. I have my y-axis and my x-axis, and right where they meet is called the origin. Okay, good all to know. You also need to know the point like 3, 2. 3, 2. 3 is the x-coordinate, tells you where to move on the x-axis. And the second number 2 tells you where to move on the y-axis. So 3 over and 2 up, there's my point right there. So I want you to copy this down, and I want you to use as many vocabulary words that we just learned to describe the graph. Try it out. Okay, so I'm looking at this. There's a couple things I did say. I said, look, on the coordinate plane, that's this here, the ordered pair, 3, -2, that's an ordered pair, has an x-coordinate of 3, that's that, and a y-coordinate of -2. The point is in the 4th quadrant, 1, 2, 3, 4th quadrant, which means the point is below the x-axis, it's below that, and to the right of the y-axis. All that is on there. Used a lot of different words to describe the situation. So now we're going to identify proportional relationships. The slowest mammal on Earth is the sloth, the tree sloth. It moves 6 feet per minute. Is the relationship proportional? And explain. All right, so I have this situation. I made myself a little table. Look, after 0 minutes, it's moved to 0 distance. That makes sense. After 1 minute, it would have moved 6 feet. 2 minutes, 12 feet. 3 minutes, 18. 4, 24. If I were to actually plot these points as coordinate pairs, okay, actually plot these on a graph here. Remember, the first point would be this point here, which is 1, 6. The next point is 2, 12. The next point is 3, 18. And the last point I have is 4, 24. Okay, so I plot all those points, I connect those points, and I can say yes. The line is straight, so it needs to be straight to be proportional, so that's good. And the second thing it needs to do is pass through the origin. Very good. So also, I could have taken these ratios, 1 over 6, 2 over 12, 3 over 18, and 4 over 24, and notice that all of them give you the same ratio. That's 1/6. This reduces to 1/6, and so do the other two. Here's a non-example. So the cost of renting video games is listed below. Is the relationship proportional? Well, like $3 to rent 1 game, 5 to rent 2, 7 to rent 3, and 9 to rent 4. If I actually plot these points, okay, where I use the x-axis as the number of games and the y-axis as the cost, the first point I'd have is 1, 3. The next point is 2, 5, and then 3, 7, and then 4, 9. So they create a straight line. Well, that's good. However, they're not proportional because even though it's a straight line, it does not pass through the origin. It's got to start at 0, 0, right? So we can tell here that it didn't start at 0, 0. Later, you're going to find out in further chapters, you can say, look, the change is $2. It looks like it's a $2 fee each game that you rent, except for the fact of here, there's an extra buck, right? There's an extra buck. Why is it an extra buck? Probably if at a video game place, it's a $1 membership, $1 to even rent, and then on top of that, the charge for the actual game. But we'll talk more about that in future chapters.